So again, we're going to go into Unit 8 stuff. On Friday, the students the exam will be opened up. Now, if you're an on-campus student, you'll take the exam in class here. If you're an online student, you have until Sunday night to take the exam. Um, we're going to use this lockdown browser. We use it in class. It just but it also is used by online students to um, it just keeps you from looking at other web pages and stuff there. It's really not that necessary in class because I'm just here and I can see what you're doing. It's mainly set up for the online students to keep them. It's not an encouragement to try to see if you can break or get around the lockdown browser. It's not that hard to circumvent the lockdown browser to do that. It's just a reminder, particularly online students, that this is a closed book exam and you're not supposed to be using AI or the internet or books to answer these questions and do this work for this. So just a reminder to uh, do the right thing and be on a same playing field as everyone else with this. I will generally score. I do. I mean, we're in the same section here with the online students and the in-class students. I'm talking about the online students in the camera here and my on campus students. In the end, you are actually broken into separate sections for grading and stuff like that. So when you were graded and how you're graded is might be different with the online students and the in class. Generally, it's the same there. So uh, for this, but again, sometimes you'll see slightly different results here. Um, so we're just going to go through this mid-term topics and midterm reviews today and look at those ideas, do some reviews for this stuff. Um, again, I'm just going to go, I find it useful just to go back to the beginning and walk through this stuff. Um, go back to unit one, where we talked about, what is a computer, what is a computer program, what it means to compile a computer or write an algorithm there. And I don't have any set definitions I need you to remember for these things, so hopefully you have ideas about what, a computer is just some sort of machine that will execute programs or instructions that we give it here. Program again is what we're doing, we're writing. And so, how would you describe a program? A program is basically a set of instructions and data that a computer executes here. Um, we have to compile a program, and we see that sometimes when we run a program. It used to be you have to hit a separate compile button, but now when you hit run, it compiles your program, and that translates this high-level language, and we're using Java, into a a language the machine can understand, and we call that generally machine language there. So compiler is just doing that. We talked at the beginning a little bit about what an algorithm is there. And, that is, we talked about like a recipe for baking you might want to make there. Or I think we looked at an algorithm for tying your shoe instructions. So basically, it's instructions that can be, that you can give to someone and they can repeat that process here. On my mind, all this stuff is also covered pretty well in CS Principles. So you're currently in CS Principles, or if you've taken CS Principles, that should sound familiar. All that stuff is basically also covered in CS Principles, I think. Um, we talked about writing a Java program and how this works. We haven't talked too much about coding standards, but we're getting to, I guess we have some implied ones here. So one thing I want to remind you of, well, two things. One is indenting here. When we get to the more complex programs like this, having it indented properly really helps you to see because when you indent properly, the compiler can also draw these vertical lines. So you can see this is where the if starts and ends. This is where this method here starts and ends. Now, without proper indenting, if you just have a bunch of, things like this, and also if you put things in weird spots, um, it is hard to tell where this if statement ends. You could see this if statement and you might think it ends here, but it doesn't. This if statement ends here for this. Uh, so watch your indenting. So our standard rules, and again, if you are in your program, you can go source format and it'll redo your indenting for you. Is that inside any block, so like an if or a loop here, we indent. Also inside every block for like a new method, we'll indent a little bit more. So every time we go into a new block or a new thing, we indent a little bit more. So you can see inside this if, we've indented here. So that's the whole goal of indenting. And again, the computer will, if you do source formatting, will follow those rules basically for you. Here. The other thing is comments. We haven't talked too much about comments, but we have seen some of them. So generally, we have two ways of putting comments in. One is the / for a single line comment there, and we can put that at the end of a line. We can use that to comment out a line here so that it doesn't run for this. Or like at the start of each method, we can put that in. We can also put it at the end of the line. Like here, if I wanted to put that in, we could say initialize humidity variable. So in this case, it does the statement, and then the comments at the end of the line is just and again, the whole idea of comments they're something that humans will read that the computer will ignore. So the idea of comments is the computer will ignore those things. There's another type of comment. I don't have them in here. Let's just switch this to it. Is you can do a /* comment, and then it'll keep going until you get to another */. In fact, you notice it grays out the whole rest of the program because it thinks it's all in a comment until I hit a */. Generally, we will format those like this, so they're kind of all together sort of stuff. So this would be a comment, everything in here. And again, the compiler will generally gray out comments, showing them as something the human can read, but the computer will ignore for that. Let's talk unit 2 variables. Let's jump into the review section here for this. So like, again, some questions. This asks, these are sample questions. What can be stored in a string variable, and give some examples. But I could ask that of all other types, like what can be stored in an integer variable? What can be stored in a double variable there? And can you declare a variable to store? Or I could give you a value there and say, write a variable to store that value here. So like here, write code to declare a variable to store a person's heart rate and store 72 in that there. So what are some options that you can run? So I'm just going to create a new project and start doing some review code here. Again, how would you declare a person's heart rate and store 72 in it? Well, I could think of three different ways of doing this. I could declare a string, uh, and store 72 in that. I could declare an int and store 72 into that. Or I could declare a double and store something in like that. So, of these three ways of declaring someone's heart rate, is one better than the other? And why would you use one way of declaring a heart rate rather than another way here? Any ideas? Which one would you suggest? Would you like? Would you like to use a double, an int, or a string to store someone's heart rate?
I would use N
Okay, and why?
because it's entity.
Because it is an integer. Okay, so yes, when you measure someone's heart rate, you can't have a heart rate of 72.4,
Yeah.
right? It is just how many beats per minute. So it's an actual integer value, right? There. So again, if it when we look at someone's heart rate, it's never a decimal value. So I mean, although you can store it as a decimal, there, uh, we wouldn't need to because again it should be an integer, so I agree there. There now you could store it as a string. One problem with the string is if you ever want to do any math on it or do some comparisons on it, so like maybe we're doing our heart rate and we're going to want to compare if it's in your target heart rate for exercising, so we'll calculate your maximum heart rate and 80% of max and see if you're in a cardio range or something like that. If you're doing that sort of comparison, it's better to do it with numbers rather than strings here. So again, I would suggest that integer would be the. So when you see something like this in the program, in the exam, ask yourself, yeah, what is the data? Is it a number or is it a string? How should I, is it words? Can it ever be words? Something like that. How would I store that? And then, yeah, what type of a number is it? Because generally we're looking at three main variable types, right? We're looking at strings, integers, and decimals or doubles is what we're using for that. So like up here, what data type store a string? Give some examples here to store that. Uh, um, Now, where would I see something like this that might be a string value? Maybe if it was some text with it. So we didn't want to just store 72, but we wanted to store maybe a range of values, like we said in a word. So we want to say between 72 and 78 or something like that. That would maybe be a string, and we generally would show those as a string there. How about legal names? Uh, which of these are legal names? So again, the idea here, let's say we're declaring a string for someone's name. Uh, okay. So first name's okay there. What about first space name? That's going to give me an error here because, again, it sees two names or two variables here. Now, how about first name, all in caps? Again, one thing I'm watching is I'm watching if it's just underlined and then it'll say a warning, or if it's red over here, it'll be an error. So it's just giving me a warning that that's not used below. So, is first name legal? Yes. Is it one we commonly use? We generally don't capitalize variables, but you certainly, there's nothing uh, illegal about writing it there. Um, Same, can we put numbers in there? So we could say name first. So we can have numbers in a variable here. Um, how about this one? First name. That's giving me an error. Why does first name give me an error? What's wrong with that variable?
Um, isn't it, isn't it because it's starting with like an integer?
Yeah, yeah. Variable names can't start with a number or something. It just has to start with a letter generally for that. And again, if we say first and we put in a special, oops, if we put in, like first name is okay, first plus name is not. Because then it's thinking you might have two variables, first and name, and you're adding them together here. So that's not allowed. So we can talk about what's legal and illegal with names. We can also just talk about what is the general practice or coding standard for writing names. For us, we'll tend to use what we call camel case. We'll start variables with a lowercase letter, and then all of them will be lowercase until we get to another word, and then we'll have that start of the word an uppercase letter. Uh, so if we were to say like patient first name or employee first name, we'd want actually that start with a lowercase, and every time we get to a new word, we do uppercase. And again, that's not required. That's just a coding practice for this. And the same thing applies to procedures. When we write procedures, we'll tend to do like retrieve weather, lowercase until we get to a W here. Now, sometimes we will put in some uppercase. When would we, is there, the one time we tend to capitalize is if it's a constant or a fixed value that we're never going to change here. So, um, can you write code? Write code, ask the user for their age and reads it into a variable if you start with this here. So if I start with a scanner, can I ask the user to enter the scanner? So can you do that? And again, so this is good. If you can't, hopefully it's time you've used scanners, 20 times here. And you've worked with them, and so you don't, you know how to use them. But again, if you read something like this, enter their age and do this. One thing to remember is that we want to prompt the user before. So we could just go, you might want to say like int age equals input next int. But again, we generally want to prompt the user for that. So we want to do a system.out.println. Enter your age. And then read that in. Let's talk inputs here. So what are the different inputs that you use? So there's next int, there's next. What do we use for a float here? We use next double generally for that. And what do we use to read in a string? There's next line. To read in that. And again, that's going to read in something for their for not an integer, but so it's complaining because this reads in a string, and we're trying to store it in an integer, and so that won't work. So again, we have to make sure we align those correctly. Questions on inputs and reading inputs? Is that um, how about some arithmetic stuff over here? Um, Here we say like int number of credits equals 4 plus 4 plus 3.1. Again, you should know how that we're just doing math here. Most of this stuff is pretty well straightforward math. What are the challenging, the weird math things that a computer will do here for us? So let's look at this code here. Is anything weird with that? So if I say number of credits is 16 divided by 4, 16.0 divided by 4.0, that's a weird way of writing that here. So if I run that, I'll get 4 credits. What if I change this to a different value, like 3 here, and run that? I'll get 5.33 here. And again, that tends to make sense. I mean, that's how division works. You type that into your calculator. What if, so the one trick is that the computer handles integer division different than decimal division. So this command is going to give us a weird answer because we're dividing two integers, 16 divided by 3. So what is that going to print out here? What is in integer division? What is 16 divided by 3 for this? So rather than saying 5.33, this will just give us 5 here. So the one thing that's probably different than what your calculator does is if you do integer division, divide two integers here. And then with integer division, we also have the mod operation. So there's another operation. We haven't really talked about it, but too much. It's not that common, and that is the remainder operation. So if we say 16 divided by 3, the remainder is 1. So 16 divided by 3 goes 5 times 5 times 3 is 15. 16 minus 15 is 1. The remainder is 1 when we do that division here. So that's one reason why this. So that's why here we're actually writing this to make sure it's clear, these values as doubles and not as integers. Other than that, I think all the rest of the math rules work like you learned early in elementary school. You know, the order of operations, that you do multiplication before you do addition, things like that are all pretty standard. We talk about variables, declaring variables, the basic data types, naming conventions, arithmetic operations, and scanners. Here. Any questions on this stuff? Again, hopefully this is kind of old hat as this. Again, all right, and when we first learned this, I think this may have been kind of hard to get your hands around. But again, it's like any exercise. We've done these variables enough that now it's seeming routine here. So okay, let's jump into if-then statements here and Boolean operators. Uh, so what is the value of a Boolean expression holds? And when you use an if-then statement, well, when would you need to add an else to an if-then statement? So let's just look at this example here. We're going to have the user enter their age. We actually have that here already. And we're just going to say if the age is greater than 17, say you can drive, else say you need to take the bus. So what will this do if I run this and I enter an age of 15? What's it going to print out for us? And again, you should be familiar now to go through again and realize that it's not going to print off both of these. They're in an if then, so it either does one or the other of these. That's what the else does. If this is true, and what is true, if this expression is true there, then we do this. If this expression is false, we do this here. Again, if we run this, what if we say you are 17 there? What is going to say? It's going to say you need to take the bus because 17 as the age is not greater than 17. It's equal to 17. How do we check if it's equal here? And what are our options here? So again, we can do greater, we can do less. Those are easy. We can do equals, and again, we have to equal equals here. What happens if we just say equals here? We'll get an error saying incompatible types cannot convert to Boolean here. That needs a Boolean, and this is a legal thing, set age to 17, but this is an assignment, so we need to do equal equals here. We have greater than or equal to, less than or equal to there. And remember, it has to be one way. You can't say this. You can't say equal greater than. Remember, right? You have to say greater than or equal. And again, same with less than or equal there. So those are your main comparative types for this, for numbers, and they work for both integers and decimals. What if we're trying to do strings here? So what if we want to, I'm going to comment this stuff out. And well, I guess that's next. We'll wait, undo that. I'm going to do strings. That's in unit 4. Let's do the more complex operation here. This one, the ands or the ors. So we read in the age and we say, if the age is greater than or equal to 12 and the age is less than or equal to 14, we say, welcome to middle school. Else we say, sorry, you're not in middle school for this. So if the user enters a value of, let's say 15, what will be shown here? So I run this and I enter an age of 15, it's going to say, sorry, not in middle school. Big old suggest is that every year I have to rewrite about half of the exam there. So if you find an exam from last year, you should be able to find about half of the questions there. We write about half of the exam every year there. But it's always a challenge because I need to write exams that aren't um, where people with certain backgrounds don't um, have an advantage. And again, this one I think some people, if you know, if like you grew up in a lot of places in the United States, you know what middle school is, but I don't think it's a common phrase in in Europe. I don't know where in Ghana or other places if you call something middle school or not there. So when I this is okay, I think for a review question, but I generally would not write this as an exam question. I'll just warn you, exam questions tend to be very boring because, again, I'll do a review questions about sports, so I can ask you soccer questions or football questions or disappointing basketball questions here. But again, if you haven't played those things, not familiar with it, sometimes it takes you a little longer to figure out or understand what that question is here. And so, I'll just tell you, most exam questions are about students because I know you are a student, and so I'll ask you about things like enter a grade or something like that. So, if you're doing this exam, like I say, I've rewritten it quite a bit of it. This one I actually rewrote. I got probably 3/4 of it. Let me know if you see anything that you think is somewhat doesn't put everyone on an equivalent playing field here as a student. Um, so like this one is actually set up so that you might know, well, a lot of middle schools are 3 age or years, and this would be about right there. How would we do this to print out something different? What if we wanted to, this is saying if age is greater than or equal to 12 or less than or equal to 14. What if we wanted to print out one thing if they're less than 12, another thing if they're greater than 14? So I want to say you're too young for middle school, or you're too old for middle school, or you're the right age for middle school. What are some ways of doing that here? Here. So again, think of that sort of stuff. Think of how, again, when you're reviewing this, I would try to come up with little practice problems for you to do that you can do. If you want an AI is great at coming up with review problems if you ask it here. So, uh, and here we just have some sample ones. How would you write code to print out the smaller of two variables here? So can you write, something that prints out this? We didn't talk too much about final ones, but in this chapter. So when we declare a variable as final, it just means that that variable is a constant and isn't changeable. So like in our program, we might declare a variable like here. Trying to change this. So I might want to say maybe we have a variable for the driving age here. So int minimum driving age equals 17. So then we could put that in here. We could check your age against the minimal driving age and do that. Now, this is a variable we're never going to change. The user never going to input this. So it's common to label this as a final variable. And then we'll also generally capitalize it. Minimum driving page. Or something like that. So final just means it's a variable that we're not going to change anywhere in our program for that. And again, we tend to capitalize those just as an indication as a coding standard. We don't have to, but we tend to. So. Oh, why don't you spend some time going through and doing some of the review problems here? So you can go into the content and go back to any of the review exercises. I actually think if I go, let's go to X at 8. Um, This one lists all links to all the practice problems. Why don't you try to pick one of these practice problems and just do it here, or look through the solution here and take some time seeing if it does. I would do the first 4 units there. Again, what we're getting into the 4th unit is how we compare strings with like user choice dot equals rather than saying equals equals, and then more complicated if structures here. So see if you can do, why don't we spend some time having you do one of the practice problems here. And then maybe we'll pick one of the problems and go over it here. Okay. So a couple final notes on the exam. It's closed book and notes, but I don't think you should have to memorize a lot of things. So, like how you declare a scanner, you should know how to declare a scanner, but you don't have to necessarily memorize this. Like system.out.println, you've done that enough, you probably remember that. But again, you won't necessarily have to because again, the exam, although it's closed book, will be like similar to this review question in that it will have code. It'll say like, what is the output of this code, or what does this code do? It'll have sample code in it there. So, there'll be at least one problem that has a scanner there, and there'll probably be another problem that asks you to write a scanner there and use it to input things. So there'll be examples of most of this stuff on in the code or on the exam here. One of the things is that time probably will be important. There are 20 questions on the exam, and you only have 65 minutes in class or online there. So you should be able to answer like multiple choice questions in about 2 minutes a question. So you can, read a little bit of code and tell what it does. Like here, you should be able to read this code, figure out what it's going to print out, or read this code and say what it's going to print, like this code, and say what's going to print out in under 2 minutes there. And then there'll be 2 slightly larger programming problems where you'll have to write a more complete program. There might be some short answer ones where I have you just, like declare a variable. Some of these like do write code that, well, like this, and then there'll be a couple one that'll be a little longer there, like ask the user to enter 2 numbers and print out the largest of those 2 numbers or something like that there. So there'll be, most of them will be short multiple choice or short answer questions there. And there'll be 2 slightly longer ones. None of them probably will be on the size of these practice problems. I don't know, unless there's a practice problem, I figure the longest problems you should be able to spend 10 minutes doing on the exam. And I still think most of the practice problems require you to probably spend more than 10 minutes doing them. So there might be like a shortened version of one of the practice problems here. Any last questions on it? We're going to review the last couple units, 5, 6, and 7 on Wednesday then. Sound good? Sure.
I have to go over it because I don't remember. Wait, how do I do that so that it's not in the same domain? Because I was just trying to do the first one.
Right. So just do print line, print LN.
Oh,
Right?
instead of doing print?
Yeah.
Okay, and then it will.
And then it'll do yeah. So if you say print, it goes on the same line. Print LN, we'll go to the next line.
Okay, and in this case, I had like they had to choose this Fahrenheit or Celsius. So if I just put 50, like saying that it's Fahrenheit, right? Then it's not called like it's thinking I'm putting it Celsius. So
Right. Yeah.
how do I?
So
Or I should do another if statement.
well again, so if you want them to choose between Fahrenheit or Celsius, you should have them enter one of those.
Okay.
There. So you should they have to enter two things, the temperature, and then if it's Fahrenheit or Celsius.
And then it will recommend.
And then you can write the if then. If if they enter Fahrenheit, then check if the temperature is less
Okay.
than this.
That makes sense.
Okay.
Thank you.
I don't think I'm gonna be here on Wednesday. I have
Okay.
away soccer.
Sounds good. Yeah, we'll do this and I'll record it and post it there. So you'll be fine.
Thank you.
So, yep. Yes.
The practice problems, like how are we supposed to submit them? Let's say because each practice problem for each unit has like a ton of.
Yeah, so if you want to submit them for credit here or for extra credit, so you can go switch to student view. Yep. You can just go in here, extra credit for practice problems, and then submit a reflection here. So submit your sample solution along with your reflection here. So again, if you just have a created document, and so you just have to pick one of these tabs.
Oh, okay.
You don't,
So
yeah.
I just have to do one out of
them. Right.
I'm getting it wrong.
Yeah, right. Yeah, you don't need to do all
Yeah.
just one of them.
Yeah.
So pick
Okay,
one of
so-
them and do it here. Here.
So let's say I pick unit 5.
Right.
I'm gonna take one.
Right. So maybe
say-
you do this one
Yeah.
and do this one.
Yeah.
So
And I
then
go to each unit and do one of each unit.
no, you just do this one.
Oh,
Okay.
but then it says that you have 5.
Well, you can do
entries.
so you can submit once.
Yeah.
So you can do the second tab for unit 5.
Okay.
And then you submit that.
Okay.
Okay. So you submit the code and you do the reflection.
Yeah.
You get points for that.
Okay. What
But
if-
then you can read. So you can have multiple submissions.
Okay.
Then then maybe say, I'm going to do units.
Yeah.
Well, I don't know. Let's do unit 4. And I want to do this one. I want to do the Northern Lights in unit 4. So you
Okay.
do that, you submit it and submit the reflection.
Okay.
So yeah. So for each one, you'd submit it and you can set 5 different ones.
Oh, okay.
Okay.
Okay. Okay.
Sound good?
It sounds good.
Okay.
Thank you so much.
Yep.
And then about the unit 3 book lookup, you told me to do it again, so I did it again. So,
Okay. Yes. I'll try to get to
Yeah.
grading those.
and then about the appointment yesterday.
Yes.
I was confused because I've never used Zoom for
Zoom?
an appointment. I thought
Okay.
maybe I had to wait to get
Right. So do you
an
have
ID.
Zoom? Right. So
I have it, but I don't know really know.
so if you look, it probably shows up. Do you use your Google Calendar at all?
Yeah. Okay. Then probably I might schedule another appointment for like an in meetup or something.
Right.
Yeah.
So when you're here,
Mm.
you should be able to just click on this link.
Oh, okay.
All right.
Yeah.
And then, okay, actually, let me stop. I have Zoom already running. So